Hello guys, and welcome to another tutorial. Today we're going to be solving a balanced bracket. A bracket is considered to be one of the following characters. We have parentheses, curly braces, and brackets. Two brackets are considered to be a match if the opening bracket occurs to the left of the closing bracket of the exact same type. A matching pair of brackets is not balanced if the set of brackets it encloses are not matched. What I've done is copy the inputs and I've taken this to a whiteboard, and we're going to talk about how to solve this problem. But if you're watching this video, most likely you're a programmer, or you are solving problems, preparing for interviews, or you just want to solve this for fun. But you see this all the time when you actually write code, and this is used for conditional statements. These are useful for scopes. For example, when we create classes in some languages. This is useful for when we want to create arrays with elements. These are useful for when we want to go ahead and access locations in an array. When we use subscripts, we use brackets for those. And our IDE has to constantly check to make sure that we're not actually missing a bracket or parentheses or a curly brace, right? And so what we're trying to do is pretty much mimic the same process here. And the parentheses have to occur at the right matching. So if you're taking compiler construction, you know that all languages have a lookup table for their symbology, right? So in this case, what we want to do is have a lookup table that is going to give us the value for every key. How you represent the value and the key depends on how you actually want to solve this problem. Because for some cases, you can actually have the closing brace as the key and then the opening brace as the value. But they're all unique symbols here, all right? So what we want to do is have a lookup table where we have the closing bracket and the opening bracket. And when I say open and close bracket, I mean curly braces as well and parentheses included. And then we need to use a stack to keep the ordering. So let's go to Whiteboard. And it seems like I have reached my limitation in the replan, but that's okay. And I'm going to go ahead here and use the first example. So we have a curly brace. Sorry, I'm using my mouse on this. And then we have a bracket. And then we have a parenthesis. Then we have another parenthesis. We have a bracket. And we have our curly brace. And what we want to do first is keep a lookup table. And for each closing brace, we're going to have an opening brace as the value. So we're going to have our curly close here, and then we're going to have an open as the value, and we're going to have the open, the close parenthesis and an open parenthesis, and then we're going to have a close bracket and open bracket, and then we're going to have our stack data structure here. All right. So what we're going to do is when we see an opening value, we're going to go ahead and put that on the stack. And then when we see a closing, we pop the value from the stack, compare those two values to see if they're actually equal to one another by looking at using the key to look at the value of the key. And if the value of the key matches the actual value on the top of the stack, then we have a pair. If it doesn't, then we just go ahead and return null, and we don't care about the rest of the brackets in the string. So what we do here is we are on the first character, right? It's an open. So what we're going to do is put this on the stack. So we're going to have our curly brace. Then we go again to the next character, and we have another open. This is going to be a bracket. We put on the stack, and then here we have another open. This is going to be a parenthesis, so we're going to put that on the stack, right? And then now we come here and we have a close. So when we have a close, what we do is we go to the map, and we're going to look at, so the close is going to be the key. We're going to look at the value. So the value for this is actually going to be the open. we compare these two to see if they actually match one another. They do match. So what we do is we remove this from the top of the stack. So we erase this. Now the topmost one of the stack is going to be the bracket. Now we go to the next one. Here we go to our lookup table, and you guys can see that the value for it is actually the open. We compare the two, we pop this and we compare the two, and they're equal, so we keep going. And then we take the last one, and this is going to be, so when we pop this, this gets away from the stack, and this is the topmost one of the stack. So I'm just trying to mimic this without erasing everything. And then here we go to our lookup table again. We get the value here, which is going to be an opening, and we check that, and we pop this and check this, and this matches. So we're at the end of our string, and it has all the matching, right? At the end of this, we still have to check to see. So once we pop this, right, this is going to be out. So now our stack is completely empty. So at the end of this, we still have to check to see if the stack is empty or not. So for example, what we can do is this. If we had an extra character, right, like this at the end, right, then the stack is going to have another one in there, but we don't have any other thing to actually pop it out. So we're thinking that, oh, we've gone through everything within our loop and it's okay, but it's not, because we have something left in the stack that we didn't account for. Okay, so we need to check for that. So the best way to do this first is to check in the beginning to see if the number of characters within our string, right, mod 2 is not equal to 0. So if we have an odd number of brackets, that means that we don't have enough brackets to actually fulfill looking for pairs, right? It doesn't mean that the brackets are in order if they are all even. However, if they are odd, it just tells us that we don't have enough brackets within our string to actually compose two pairs. All right, so we can go ahead and just exit immediately if the number of brackets within our string is actually even if it's actually odd. Okay, so I'm gonna go ahead here and just erase this, and we're gonna erase this, and I'm gonna erase this as well. So now we're gonna do the second one. I'm gonna go, it's gonna be curly brace, bracket, parenthesis, bracket, parenthesis, and curly brace. So we're gonna do the same thing. We're gonna keep our stack here. All right. So we see an opening, we put that in the stack. We see another opening here, we put this in the stack. And we see another opening here, we put this in the stack. Okay, so now we see a close. So we go to our map, we get the value, which is actually going to be a bracket, and we pop the topmost stuff on the stack, which is actually going to be a parenthesis. So obviously these two are not equal to one another, so we just go ahead here and return false, all right, or we return null. So you guys can see that by using the stack, we can keep the ordering of the actual closest pair, right, that is supposed to be the right pair. And if it's not the right pair, then we just go ahead and say, okay, we're done. This is not balanced. And we can do the same thing for the last one. So I'm going to go ahead here and cancel this. Oops. I don't think I can redo this. Oh, I can. All right. So let's do that. And let's do this. I'm going to go ahead here and draw another one here. And I'm gonna, we're gonna have we have a curly brace. I think this is another curly brace. We have bracket, bracket, parenthesis, 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 bracket, bracket, curly brace, and curly brace. So we see an opening, we put this in the stack. We see another opening, we put this in the stack. We see another opening, we put this in the stack. We see another opening, we put this in the stack. Alright, and then we see another opening here. So we're going to put this in the stack. Have another opening, we're going to put this in the stack. Alright, so now we see a closing. We go to our map here and we get the value, which is going to be another parenthesis. We pop this from the top of the stack, right? And we compare these two, so that checks out. So we're going to pop this from the stack, right? So that's gone. So we come down here. We have another pair. Right here, we go to the top. Right, we go here, and then we take the key, look at the value, and it's going to be this. Right? We pop the next thing on the stack, which is this. They're equal to each other, so we take this off. Right? So now we're here. There we go. So we're here now, right? So we go to the stack, we have a bracket, and we get, we're going to get the value. We check up top, and it's the same, so we do that, and we pop this off. And the next thing we want to do is go again to the next character, and we have another close bracket. We look at the value using the key, and we have another open. We look at what's at the top of the stack, it is another open. So they're equal to each other, so this checks out, and we take these off. And then we go down here, we get the value from the map, which is going to be an open curly brace. We look at the top of the stack, it's an open curly brace. Right? These are equal to each other, so we take this out from the stack, and we're now at the last character. Right? So we have we get the value from the map, which is going to be another open. We look at what's on the top of the stack, is going to be another open. We check this, and we take this out. And remember that at the end, we still have to check to see if the stack is actually empty. And if it's empty, then we go ahead and return yes. So we've seen how to actually solve this using all of the examples. It's time for us to actually implement the code for this. So what we're going to do is scroll down, and the first thing that we want to do is check to see if s.length, right, and 1. So we're going to see if it's actually if it's odd. We want to go ahead and return no. So we're going to see if s and 1 is not equal to 0, meaning that it's odd. We're going to go ahead and return no. All right. Next thing to see is we're going to check if s dot is empty. Then we're going to go ahead and return yes. Okay, so next thing we want to do is create our lookup table. So we're going to create a map for this. There's a map. The key is going to be a character, and the value is going to be a character. And let's just call this one pair. We go to new hash map. And then we're going to go ahead and manually add in our pairs. If we were using like Java 11 or 12 or 13, then we can just use map off and it'd be a lot easier, but we don't have those capabilities with Java 8. So for every open, right, for every close, we need an open as the value. So go ahead here and do that. And I'm just going to go ahead and copy this and duplicate it so I can create the other pairs a lot easily. So we need our open bracket, and so close and open, and then we need the parentheses. All right. And then now what we want to do is go over the characters within our string. So we're going to say for char, call this one bracket, and s.to char array. You can start processing some logic here. So what we want to do first is check to see. So we're going to say if pair that contains key bracket. Okay. So in this case, what we want to do is we want to actually put only the open brackets, right, in our stack, right? We want to put only the open brackets in our stack. So what we're going to do is we're going to say if pair does not contain key, then it contains an open bracket, because we're using the close bracket as our keys, right? So the alternative will not be our close bracket, right? So we need to put that in a stack. So we need to actually create a stack for that. We're going to say stack. This is going to be a character stack. Let's call this one stack. I'm going to equal new stack. So what we're going to do is we're going to say stack dot push bracket. Okay. Else so else we know that the actual character is going to be a closing one, because we already checked for the opening one. So the next one is going to be the closing one. But this is a little tricky part about this problem. If you actually have this thing like this, if you have characters like this, and then you have like close ones like this, right? This is going to pass the initial stage here, because this is actually going to be even, right? However, if you see at the beginning, if you see an actual closing before there's ever an opening, that means that the string itself, the actual brackets, are malformed, right? So when we see something like that, we can immediately say, okay, you know what, exit here, because there is no reason for actually continuing, right? So when we actually go and find this, eventually, when we find another closing, let's say for example that we found, we added this to this, and then we found a closing. Sometimes this will actually cause the stack to be empty, right? So what I want to do is check to see if the stack is empty. If the stack is empty and we have a closing, right, that means that it's malformed. So we need to handle this a little bit more gracefully. There are ways that we can do this. The first thing is to check to see if the stack is empty, or if the value that we find using the key is not the same, then we go ahead and return a null. But what we can do is gracefully handle the stack is empty exception by using try catch here. So we're going to say try, and then we're going to have a catch, and when this fails, I'm just going to go ahead and pass exception here. And when this actually, so if this becomes empty and it throws an exception, what we're going to do here is just return null. Okay. So now what we can do here most easily is just check and say if pair dot get bracket, right, is not equal to stack dot pop. That means that the pairs are not matched. So what we can do here is return no. And at the end, we need to check to see if the stack is actually empty. So we're going to return stack dot is empty. And if the stack is empty, we're going to go ahead and print yes. Otherwise, we're going to go ahead and print no. All right. So this is the problem. So what we do is we go down here, go to each character, and if it's an open, we put that in the stack. If it's a close, what we want to do is get the key by using the close, which is going to be the open. We compare that to what's at the top of the stack. And if those do not match, we return no. However, if we have an opening, right? If we have a closing and the stack is empty, then what we want to do is we want to gracefully handle that. So we're just going to go ahead and return no here, right? Because there's nothing to compare that against, right? And then at the end, we need to check to see if the stack is empty after we've exhausted all the characters, because there could be an opening, but there was never a close to actually pop it out of the stack. So I'm going to go ahead here and run this code, and if there are any errors, we're going to go ahead and fix those. And this passes, and let's submit. Alright guys, this will be it for this problem. I appreciate your time. I will see you guys in the next Hackerrank video. Have a good night. Bye bye.